Regulatory Commission and electric power regulation and electricity markets. I'll tell you a little bit about the policy office to start out with. And we'll talk a lot about what the Federal Energy Regulatory Commission is during the presentation. The policy office job is to coordinate policy development across the program offices at the Federal Energy Regulatory Commission. A primary job for the policy office is to identify emerging issues and get smart on those issues so that the Commission is prepared to take action if an issue were to come before the Commission. As part of that role, the policy office, along with all of the other program offices at the Commission, helped organize a series of conferences during the winter on EPA's Clean Power Plan. We held 2 conferences in Washington, D.C., one a national conference, the other one a conference focused on the East region, and then we held 2 regional conferences, one in Denver and one in St. Louis, where we talked about how the Clean Power Plan could potentially impact some of the things that the Federal Energy Regulatory Commission has jurisdiction over. And those things included, as we'll talk today, things like reliability, infrastructure, and electricity markets. So again, very happy to be here and talk about electricity markets and how the Federal Energy Regulatory Commission fits into regulation of those markets. Because I'm a government employee, have to start out with a disclaimer that my views represent my own views and do not necessarily represent the views of the Federal Energy Regulatory Commission or the United States government. So I thought I would start with some very fundamental basics about the electric power system. One, so that we all can start on the same page and with the same fundamentals. Also because those fundamentals actually have a lot to do with what the Federal Energy Regulatory Commission regulates and what the states regulate. So, the typical power system drawing, and this has been the drawing that we've had for almost 100 years, has a central station generator producing electricity, usually located fairly far away from where people want to use that electricity. That electricity travels over high voltage transmission lines, the stuff that's in blue there. It goes over high voltage because that's the most efficient way to send electricity long distances. And then it gets stepped down, that's the engineering term, but I won't do a lot of engineering today. Gets stepped down to a lower voltage, a voltage that industrial customers, commercial customers, and residential customers can use. Again, this is the typical picture. This is what it's looked like for almost 100 years. This picture is getting blurred a little bit, and that'll be a theme that kind of comes across as we talk today. More and more generation isn't being sent over these long blue transmission lines, but more generation, especially solar photovoltaic, is being put on the green part of the system. And that has some important implications for electricity markets and how they're regulated. I won't do a lot about the mechanics of electric power generation, other than to say that it's a marvel. It's one of the most impressive machines in the world. It's important to recognize in that red circle that kind of is around the turbine, which is the body that is spinning, or it helps to have the generator spin. That complex is connected to the transmission system. And that's really the important point from this slide, is that all of our generation, except for that stuff that is on the distribution system, connects to the transmission system and responds to what's happening on the transmission system. So if something happens on the transmission system, most generators are going to automatically react to that. And so this big machine is very, very interconnected. And we use this phrase synchronized to define kind of how this big machine works across very large regions. The country is broken up into what we call interconnections. These are 3 areas where the entire system is synchronized to be reacting and responding to exactly the same phenomenon. So the eastern half of the country is on kind of one synchronous cycle, so that a disturbance in Maine is felt in Nebraska to some extent. If really small things are felt very little. The western half of the country is on this a different synchronous cycle. And then the state of Texas, or at least part of the state of Texas, is off on its own, and it's also on its own kind of separate synchronous cycle. There is trading across these parts of the country, but it's fairly limited, and it's very directed, so that what happens in the east actually does not affect what happens in the west, or doesn't affect what happens in Texas. That's how the machine works. It also turns out, because the machine is regional, that the regions tend to, on many issues, coordinate. So the Western Interconnection will the states in the Western Interconnection, and also the Canadian provinces, as you can see from the map, will coordinate on issues like reliability, sometimes issues like markets, and certainly as they all start to think about compliance with the Clean Power Plan, they'll start to talk about the degree to which they're going to coordinate, and then what all that will mean for the other things that the entities in the Western Interconnect or the Eastern Interconnect or Texas have to do. I'll do a little bit of history to maybe provide context for why there is a federal regulator of electricity markets. In the very early days, electricity didn't have to travel very far. In fact, the technology didn't allow it to travel very far. So most utility systems were kind of built up kind of from a very local area. You had individual generators serving a very small number of individual nearby customers. Over time, the technology improved so that electricity could be moved greater distances, and also that it became clear that bigger and bigger generators were more cost effective, and to get the use of those big generators, you needed to get more customers. So the scale of the industry kind of grew from this very small local scale to a larger, close to statewide or region-wide scale. And at first, all the electricity basically stayed within a state jurisdictional line. And so the states were the entities that regulated the production of electricity, the price, and also served this kind of very important consumer protection role. In 1927, there was this landmark case, and in adjudicating the case, it became clear that state regulation worked up until the point a utility in one state was selling to a customer in another state. And the moment that happened, if you didn't have a federal regulator, you would have one state regulator setting prices for customers in another state. That looked like it was prohibited by the Commerce Clause, and as a result, we got what was called the case was a utility called Alberta Steam and Electric. We got what we called the Alberta Gap. And the Federal Power Act is the act that created what became the Federal Energy Regulatory Commission. It is the foundational statutory responsibility that my commission has to operate under. The Federal Power Act kind of fills that gap and creates a federal regulator with a set of very specific responsibilities. So what are those responsibilities, and what's left for the federal regulator or FERC, what's left for the public utility commissions? I won't read every single one of these bullets, but on the wholesale side, or on the federal side, it's wholesale sales of electricity. It's the use of the transmission system. It's very limited backstop authority to do transmission siting. On the state side, it's regulation of retail sales of electricity. It's regulation of the low voltage distribution line. So going back to that very first picture, federal has jurisdiction over the high voltage green lines, or I guess I can't remember what color. I guess those high voltage blue lines, and state has jurisdiction over those low voltage green lines, and states still maintain the responsibility to site power plants, site transmission lines, and very importantly, continue to have the role to plan the system to make sure that there is sufficient transmission and generation to serve retail customers. What will become clear as we talk is that there's actually a fair amount of overlap between a lot of these responsibilities. And while the federal government and the state governments try very hard to coordinate and identify kind of clear places where jurisdiction moves from one regulator to another regulator, the overlap is there. And so, for instance, the states have this responsibility for making sure there's enough generation, but how much generation you have definitely affects how well the whole markets work. So you have the federal government and the state governments, doing things that have the potential to interfere with what each other does, and a lot of what we do is try to coordinate those activities. The Federal Energy Regulatory Commission, which is the successor to what was initially created by the Federal Power Act, which is the Federal Power Commission, is an independent regulatory agency. It's part of the executive branch. The FERC was created in 1977, but there was, again, this predecessor agency called the Federal Power Commission, which had very similar responsibilities. There are 5 commissioners. Those 5 commissioners are appointed by the president. They're confirmed by the Senate. Like many independent agencies, they serve staggered 5-year terms. So every June, a commissioner's term ends. Sometimes that commissioner is reappointed. Sometimes that commissioner leaves. But this kind of provides for a regular change in the composition of the commission. Importantly, no more than 3 members of the commission can be from any single party. So typically the party that holds the presidency will have 3 commissioners. The other party will have 2 commissioners. The president designates the chairman of the commission. So the chairman has the responsibility to identify strategic goals for the agency and has control over the agency's resources. But at the end of the day, if the commission takes any formal action, that action has to be approved by a majority of the 5 commissioners. And that results in the commission having a fairly bilateral feel. And policies by the commission don't change dramatically from one administration to another because there's this continuity both in the way the terms are staggered over 5 years and because there's always a bipartisan nature to the composition of the commission. The commission regulates, in addition to electricity, natural gas and oil. I think it's fair to say now that our jurisdiction over natural gas and oil is more limited than it is over the electric power industry, though that has not always been the case. In fact, in the 1980s, I think you'd argue the opposite, that the commission had more activity in the natural gas side and less activity in the electric power side. As I said, and I won't try to repeat much, on electric power, we have jurisdiction over interstate transmission, so it's the use of those high voltage lines, wholesale sales of electric energy, and so wholesale sale usually is thought of as a sale for resale, a sale to somebody who is going to sell that power to somebody else, and oftentimes that somebody else is someone who will ultimately sell it to a retail customer. We have jurisdiction over corporate transactions, mergers, and securities. So if 2 utilities want to merge, the Federal Energy Regulatory Commission has to approve that. Sometimes state commissions also have to approve it. Importantly, and recently, as a result of EPACT 2005, or the Energy Policy Act of 2005, the Commission has jurisdiction over mandatory electric reliability standards, and that jurisdiction came as a result of the 2003 blackout. And then we also have jurisdiction over siting and licensing hydroelectric facilities, and also the use and the safety of those facilities. And in fact, that was actually the first job of the Federal Power Commission back when the Federal Power Act was passed. On natural gas and oil, it's much more limited. Arguably, natural gas is a largely deregulated industry. On natural gas, we have jurisdiction over interstate transmission rates and services. Importantly, especially in relation to the Clean Power Plan, the Commission does have jurisdiction over interstate gas pipeline siting, construction, and related environmental matters. So if a new pipeline wants to build, the Commission has to do an assessment of the environmental impact, will assess whatever remediation measures have to be made to the extent that the Commission approves that pipeline, and then will also has a role in dictating the siting and the construction of those facilities. And on the oil side, we only regulate the transportation of oil through pipelines. And it's a much smaller part of what the Commission does. So that means that the Commission doesn't regulate a lot of things. So what it does not regulate, and this is largely regulated by the state or other federal agencies, does not regulate the planning or financing of generation investments. It doesn't regulate pollution produced by electric generators. That's done by the Environmental Protection Agency. It doesn't do pipeline safety. It doesn't do siting of electric transmission lines. So while we do site natural gas pipelines, with a very limited extent, we do not have anything to do with the siting of electric transmission lines. And finally, we have nothing to do with siting of generation plants. Both those last two roles are largely provided by us. So I'll go a little bit more into the details of our enabling statutes, kind of where jurisdiction stands. Again, I'm not going to try to read the slides and what it says, what the Federal Power Act says about our jurisdiction, except to point out a couple keywords. So we have jurisdiction over interstate commerce. That's an important element. That is, in fact, why you have a federal regulator at all. We have jurisdiction over the sale of electric energy at wholesale. Wholesale is a very important word. So we don't have jurisdiction over retail. But you see that second bullet, we don't have jurisdiction over distribution facilities. And so what this means is that for things that are at the wholesale level, over transmission, that's the Commission's job. Things that are at retail over distribution system, that's the state's jobs. But you can even see from this language, there's a little bit of overlap, and that overlap is the place where the Commission and the states have to kind of find ways to get along, to coordinate activities, and especially with the introduction of more distributed generation, largely rooftop solar, that jurisdictional divide, what is a distribution facility, what is a transmission facility, that starts to get a little bit more cloudy. Again, it just kind of reemphasizes this important coordination that has to happen between the federal government and the state government as energy policies are made. So this next slide goes through what we call the 7-factor test. Again, I will not go through every single one of the factors to decide when something is transmission and when it's distribution. Usually we can rely on voltage to be a pretty good indicator. High voltage tends to be transmission, low voltage tends to be distribution. At the extremes, that's absolutely true. It's in the middle where things get foggier. And where this 7-factor test becomes more important. Things that I'll point out about the 7-factor test that are going to start to become challenging as, again, we have more distributed generation located on the distribution system. One of our factors is that power flows into the distribution systems and rarely, if ever, flows out. That's true today, but the more solar occurs on the distribution system, the question will become whether that continues to be true. Power entering the local distribution is consumed in a comparatively restricted geographic area. Again, that's typically very easy to identify today. As distributed generation becomes a bigger deal, the degree to which that power stays right at that distribution system or moves someplace else will become more challenging. And so I think we'll start to see is some more jurisdictional questions about what the commission has to regulate, what the commission gets to regulate and what the states get to regulate. Importantly, there are a set of entities that the commission doesn't have jurisdiction over. So for the most part, if an entity is engaged in providing transmission service, so owning and operating those transmission lines, or selling wholesale power, the commission has jurisdiction, and we call those entities public utilities, and they're subject to our jurisdiction. However, and this is important, we do not have jurisdiction over federal, state, or municipally owned electric utilities. And there's a large portion of the country that is operated by these entities. So there's whole parts of the country the commission has no jurisdiction, no direct jurisdiction over the people providing transmission service. And so entities like the Bonneville Power Administration, which is a very large transmission provider in the Pacific Northwest, the commission does not have direct jurisdiction over. The Tennessee Valley Authority in Tennessee, the southeastern part of the country, the commission has no direct jurisdiction over. Entities like Los Angeles Department of Water and Power, which is a very large electric utility in Southern California, commission doesn't have jurisdiction over. So even though the Federal Power Act does not give us direct jurisdiction, these entities tend to provide the same kinds of services that entities that we have jurisdiction over provide. And so there is a sort of coordination between what the commission does and what these entities do. And at some point, the commission's jurisdiction does, to a degree, start to bleed over into the operations of these otherwise non-jurisdictional entities. So the kind of question becomes, how does the commission make decisions? What are the standards the commission uses when it decides whether transmission service or wholesales of electricity are appropriate? And our standards are captured in sections 205 and sections 206 of the Federal Power Act. The most important thing about these two sections of the Federal Power Act is that they establish this notion of just and reasonable and not unduly preferential or not unduly discriminatory. And so those really are the standards that the commission uses when it decides whether someone has been provided transmission service appropriately or the charge for electric energy at wholesale is appropriate. I'm an economist by training, and what I'm constantly reminded by my non-economist colleagues is that just and reasonable does not mean the most economically efficient. The standard that just and reasonable allows, and the courts have told us over time that there can be many just and reasonable regulations for the exact same topic. So there's frequently not one answer, and the commission is faced with picking a just and reasonable answer, not the only just and reasonable answer. So that standard and that court dictate gives the commission some discretion when it's making regulatory decisions. The other thing I'll note is if you look at these enabling statutes, nothing in there says anything about competitive markets. There's nothing that would seem to promote competitive markets or even hold competitive markets up as a thing that is good. The Commission over time has decided that a competitive market will produce a just and reasonable rate, but that wasn't part of the statutory congressional mandate. That is a decision the Commission made largely in the 1990s. So I'll talk a little bit about rate regulation and kind of build off the point I just made. Wholesale electricity, so the sale of the service, typically is made at what we call market-based rates. So the buyer and the seller decide the price for the service. We do certain things. So we make sure that the seller does not have market power, and we do an analysis, and every seller of wholesale electricity has to come to the Commission and get a determination that they do not have market power. And at that point, then that seller is allowed to make sales to a willing buyer at whatever price they agree on. And again, it's because the Commission has decided once we've determined that the seller does not have market power, that there's a competitive market, and competitive markets produce just and reasonable rates. I'll talk a little bit more in future slides about the difference between what we call centralized wholesale markets, or the shorthand of this is regional transmission organization or system organization. The slide has those abbreviated as RTO, ISO regions, where the buying and selling is coordinated by a central entity, and non-RTO ISO regions where the buying and selling is very bilateral in nature, and it's one seller calling around finding a buyer or vice versa. On the electric transmission side, that regulation is almost entirely done at cost-based rates. So a seller of transmission service typically has monopoly power. You don't tend to get a lot of transmission lines kind of in exactly the same place. It's a natural monopoly by its kind of basic physics and engineering. So because it's a natural monopoly, we tend to regulate it by cost basis. So a transmission provider will come to the Commission, establish the cost it incurs to provide transmission service. We will decide what kind of return on capital investment it deserves, and then the rate it charges to its transmission customers will be based on that cost and the regulated rate of return on its investment. One little note, especially with the increased development of wind resources, and this is particularly the kind of large-scale, utility-scale wind resources, tend to be in parts of the country which are remote and have traditionally not had a lot of other transmission around them. Developers have started to get into the business of connecting those wind-rich resources to load areas, and those developers have been able to convince the Commission that they don't have a kind of a natural monopoly, and the Commission has allowed those developers to sell service at what we call negotiated rates or market-based rates. But then we put in lots of protections to make sure that we feel we're getting what looks like a competitive outcome. So I just got done talking about how transmission service is paid for. Probably more interesting and more important is how transmission access is granted. In the 1990s, as a part of an kind of overarching evolution of the Commission's policies, it became clear that if you really wanted competitive wholesale electricity markets, if you wanted to make sure that you limited sellers' market power, one thing you were going to have to do is make sure that everyone had equal access to the transmission system, which meant that the local utility couldn't could still use the transmission system to serve their own customers, but to the extent that they had extra transmission service available, had to make that available on a non-discriminatory basis to third parties. And the Commission went through a series of rulemakings in the 90s to establish this obligation that a public utility transmission provider must make its transmission system accessible to third parties, and then set a set of regulations on how that access would be granted and how it would be paid for. It's important to understand that this access question is particularly important in bilateral regions or parts of the country where sellers and buyers are finding each other kind of through a series of phone calls or through an exchange or a broker system, because in those parts of the country, it's largely, and we'll see a map in a moment, the Pacific Northwest and the Southeast, use of the transmission system is very important for actually delivering the energy between a specific buyer and a specific seller. In those parts of the country where wholesale centralized electricity markets have cropped up, it turns out that the open access is provided through the market. So people are granted access not based on asking the local transmission provider for specific access over a certain time period, but rather by basically engaging and participating in a market. And so the market operator makes sure that all power can flow from sellers to buyers. I haven't said much about reliability, but that is, as I mentioned earlier, a kind of a new core responsibility for the Commission. That responsibility came out of the blackout in 2003. Prior to, and at the time of the blackout, there were a set of voluntary reliability standards that the electric utilities had all collectively agreed voluntarily to abide by. So there was an entity called the North American Electric Reliability Corporation. It was the kind of voluntary trade group or organization that all the electric utilities, the transmission providers, participated in. That organization established reliability standards, but at the time of the blackout in 2003, participation was voluntary. Abiding by those standards was voluntary. It was kind of like a best standard. With the blackout, Congress decided that those standards had to be mandatory, and also that the utilities themselves could not be establishing those standards for themselves without oversight from some organization. The organization that has the new responsibility to establish reliability standards is what we call the Electric Reliability Organization. It turns out that the voluntary organization that had been doing it at the time of the Energy Policy Act of 2005 became, after approval by the Commission, the Electric Reliability Organization, but the role really changed. It now has oversight from the Commission. It continues to have a very active industry stakeholder process, but rather than stopping at the stakeholder process, those standards have to come to the Federal Energy Regulatory Commission. We can approve those standards. We can ask for the standards to be revised. We cannot write standards ourselves, but we can require the standards be developed. The Energy Policy Act gave us jurisdiction for reliability only over the bulk power system, which is roughly the transmission system, around 100 kilovolts voltage and above. There are some important exceptions to that, but it's still the state's responsibility to maintain reliability on the distribution system. And importantly, while the Commission can approve standards, we can't require facilities to be constructed. So at the end of the day, if a transmission provider has to do something to make sure it can maintain reliability, the Commission can't order that the facility be built. It can just establish the standard that would lead to that facility being built. And then finally, I'll kind of round out the discussion of regulation by covering what the states do. And, given our federal system, the states do everything that the Federal Power Act does not tell the Federal Energy Regulatory Commission to do. That is largely set retail rates paid by end users, also manage the reliability and investment in the distribution system. That includes making sure that there is sufficient generation and the appropriate mix of generation. There are some states that have decided that they want to deregulate the retail side of the market. In those states, this investment in transmission and this kind of integrated resource planning is a less important feature. In some states, it's not existent at all. And we'll talk a little bit in a few minutes that those responsibilities kind of end up floating up to the wholesale market. The states regulate what we call demand-side management and energy efficiency. So a good example is when the local utility wants to put control equipment on your air conditioner so that on the hottest day they can cycle your air conditioner to save electricity. That is an activity that is regulated by the state. And importantly, the states have jurisdiction, as I mentioned, over siting of transmission lines and power plants. So as I mentioned, some states have decided that it is more efficient and in fact, in the customer's best interest to deregulate or really restructure the retail side of the market. This restructuring took hold very early. So it probably in like roughly the middle 90s to the early 2000s, there was a lot of activity. In 2000 or right around 2000, the California energy crisis occurred. California at the time was a restructured state, and I think it's fair to say that in 2000, when the California energy crisis happened, retail restructuring really started to kind of fall away. So what you're left with is largely the northeast part of the country has restructured so that there is pretty aggressive retail competition. You have the state of Texas has had a very successful restructuring in retail competition. And then a bunch of states, particularly in the West, that started a process to restructure, and then kind of that process died away. Again, largely because the California energy crisis occurred and people started to question what the value was. So if you look at this map, the place where the states have restructured, a lot of what the states used to do to make sure that customers were protected, because that's, again, a large bit of what the states are responsible for. And then, again, the important part for states was also this planning function. The states had far less control once they had restructured. And so trading of electricity became a much bigger deal. And the need to efficiently find the best way to use the transmission system became a much bigger deal. And so what we started to see were these things called regional transmission organizations or independent system operators. They're largely today, those two terms are interchangeable. They don't really have any real distinction. The role of these regional transmission organizations was to make the best use of the transmission system in a region. And I'll show you a map on the next slide. Actually, maybe I'll go there real quick. You'll see there are 7 of these regional transmission organizations, or ISOs, in the United States. There in the Northeast is New England. New York State has its own. In the Mid-Atlantic, and heading a little west is what we call PJM. PJM stands for Pennsylvania, Jersey, and Maryland. It's clearly now much bigger than that. And in the center of the country, we have the Mid-Continent ISO and the Southwest Power Pool. And then in California, we have the California ISO. So if this map looks fairly similar to the other map where there was some aggressive restructuring of retail electricity, with the exception that in the middle of the country still is fairly vertically integrated and a franchised retail provider, but the middle of the country has decided that regional transmission organizations make sense for them. So what do these organizations do? They really coordinate the buying and selling of electricity. They do this by operating energy and ancillary services markets. I'm not going to try to get too much into what ancillary services are, but the energy markets in particular are basically very frequent auctions to buy and sell electricity. The special thing about the retail transmission organizations is they take into account the configuration of the transmission system, the availability of transmission to find the most cost-effective generation to serve load with the most efficient use of the transmission system. And some of those regional transmission organizations, especially those where state retail competition is the heaviest, also have what we call capacity markets. Capacity markets are a centralized way to make sure that there is enough generation. So that feature that is normally reserved to the state is now has a difficult time doing, so the regional transmission organizations step in and take that role. Importantly, and this is something I think that gets lost a little bit, for these regional transmission organizations, for all of them, one of their most important stakeholders are the state public service commissions. And the states, while it feels like, because these regional transmission organizations are jurisdictional to the Federal Energy Regulatory Commission, the states continue to have a very prominent role in establishing the market rules and the access rules. And one more important, two more important points. The regional transmission organizations tend to be the places in the country where we see what we call merchant generation. Merchant generation are the power plants that don't have any captive ratepayers, don't have any captive customers. They're power plants that were invested in and rely entirely on market revenues. If they don't get sufficient market revenues, then the power plant will go bankrupt. If they get more than sufficient market revenues, then the investors will reap the rewards of that investment. And the other probably very, very important thing to note is that, as I move to the map, there are 7 of these entities. They have a lot of similarities, but the specific details of how each one of the markets work differ across all of them. And so the Commission, the Federal Energy Regulatory Commission, has allowed substantial differences across the markets so that regional needs can be addressed by regional market rules. There was an effort in the early part of the 2000s for the Commission to find one market design and apply it to the entire country. That was not a successful effort. Congress told the Commission not to do that. I think actually over the space of the 10 years since then, we started to appreciate the value of having this regional diversity. Again, the federal system, the beauty of the federal system is that the states can be these laboratories for experiment and for innovation, and each one of the markets kind of approaches problems differently. Each experience different problems at different times, and so the unique rules sometimes allow one market to learn from another. We've talked a lot about jurisdiction and kind of the cross between state and federal jurisdiction. There are a couple things going on right now that are important jurisdictional questions. Important, one, to the Federal Energy Regulatory Commission, but also probably important as states start to think about how they're going to comply with a final clean power plan. Demand response in the wholesale markets is one issue. Demand response, again, is any activity by an end-use customer to change their use of electricity use, usually decrease their electricity use, in response to wholesale electricity prices or to some emergency that's occurring on the system. As one of the earlier slides noted, the states have jurisdiction over what retail customers do and have jurisdiction over many of the programs. But participation of those programs in the wholesale markets has become a really important way for the system to kind of manage through emergencies. It's also a clean way for the system to manage through emergencies. So in the hottest day, in the most stressed conditions, you can turn on a power plant, and there are usually associated emissions with that power plant. Or you can use demand response, which simply asks customers to decrease their use of electricity, and that typically has no emissions except to the extent that the use of electricity goes to some future hour. Because there is clearly a role for end-use retail customers participating in the wholesale markets, questions have been raised about the Commission's jurisdiction to set rules for this resource. Those questions are currently before the Supreme Court. We expect to have a hearing this fall. The outcome will be very important for the Commission's ability to continue to have demand response in the wholesale markets, and also, what tools states have to use when it comes to abiding by the Clean Power Plan. Resource adequacy is something I've mentioned a couple times. This continues to be a place where there is active litigation. As I noted, in those states where there is active retail competition, the planning role for the state has kind of moved to the side, and the wholesale market has taken on more of that planning role, and typically done it through capacity markets. Some states, most recently New Jersey and Maryland, have become concerned about either the operation of the capacity markets or the ability of the capacity markets to deliver the level of reliability that they're comfortable with. Those states have taken action, typically to sign contracts with generators, and sometimes those contracts appear to interfere with the operation of Commission jurisdictional capacity markets. And so there's active litigation going on right now that tries to define what states are allowed to do and what they're not allowed to do when it comes to maintaining resource adequacy and signing contracts with generators. And then finally, I'll say a note about bilateral markets. So outside of these regional transmission organizations, where there isn't this coordinated use of the transmission system, there isn't this auction system where all the generators bid in and all the load bids in to identify the most cost-effective set of generation to serve load, we have bilateral markets. I think it's fair to say that there are parts of the country that, as a result of the California energy crisis, in the California energy crisis, California had a centralized wholesale market, remain concerned that wholesale electricity market, maybe they'd admit are good ideas in theory. Experience shows that you can have unintended consequences, and so continue to desire to trade on a more bilateral basis. These parts of the country tend to be characterized by having vertically integrated utilities. So you have that same old kind of traditional utility model where the utility owns both the generation, the transmission, and the distribution system. They have a state obligation to serve end-use customers, and they have the responsibility to maintain reliability within their local, we call balancing area. And balancing area just is a kind of electric utility word for area of control where they have to maintain a constant balance of supply and demand. In these areas where you have, kind of the traditional setup, you continue to see buyers and sellers trying to identify opportunities to save cost. And in these markets, what you tend to get are what we call bilateral transactions at arm's length, again, mostly at market-based rates. But the activity is far more decentralized. Sometimes brokers are involved, but a lot of the activity really are one utility calling another utility on the phone and asking whether either one of them has power to buy or sell. Once a potential transaction has been identified, then the parties have to go out and find transmission from wherever the generator is to wherever the load is. That transmission service is dictated by what we call an open access transmission tariff. It's the rules that govern access and payment for transmission service. The state public utility commissions, again, retain full authority over resource adequacy. They tend to plan the system. They tend to think about what generation to build, how much to rely on third-party purchases, what transmission to build. So it's a much more highly planned part of the system. And you also tend to see far less what we call merchant generators because for the most part, it's the vertically integrated utility that decides that it wants to build a new generator. So it's hard for a third-party generator to, kind of plop down in the middle of this kind of region and just hope that they'll be able to find, spot sales that will allow them to recover their full cost and earn a return. So with that, I'm happy to take any questions.
And your first question comes from the line of June Sevilla with Calvert Citizens.
Yes. One of the things that you said in your slide was that you do not have siting jurisdiction, and yet, in the case of Maryland in Cove Point, we had a safety issue about the siting of this Cove Point plant near a highly residential area, and then you say that the state has the jurisdiction or some other jurisdiction. So there seems to be a conflict of what FERC is able to do. The siting of this plant is definitely not even within the industry standard. So, and we've posed this question to FERC on several occasions during the hearing process, and we've never gotten an answer. So I'm confused as to whether FERC really has a siting jurisdiction or not a siting jurisdiction, or is that the state? Or could you clarify that, please?
Sure, I'm happy to clarify. The clarification is that FERC does not have siting authority except on a limited basis over electric transmission service. The Commission does have siting authority for natural gas pipelines, and so that would be the distinction. That's the difference. So for anything related to natural gas and natural gas pipelines, the Commission does have siting authority. For electric transmission, it's the states that have the authority.
Okay, so basically this thing is a natural gas. They're putting up a refinery and also transporting gas from the Appalachian Mountains. So therefore, and why was safety of the residents ignored? Because this is definitely then in the jurisdiction of FERC.
I think this is an on-the-record proceeding, and our rules prevent me from going into an on-the-record proceeding.
What do you mean by that? You can't answer the question, or?
I can't, legally I can't answer the question.
Okay. Thank you, June.
Thank you.